Okay, so we made our lists of knowns and unknowns, and we're solving for how long the ball will be in the air, how high will the ball go, and what will be its range. Okay, so first I wanted to find the time component because then if I needed to, I could use it other places. Okay. And I have a lot of information here in the y, and so I chose an equation that does not contain y final because I don't have that info. And so I chose the first equation here, and then I recognized that my initial velocity was 0. Okay, and then after I did that, I'm going to rearrange the equation to solve for that unknown, and I'm looking for time. So subtract velocity initial, and then divide by the acceleration, and that will tell me the time component. Okay, so that's what I got for time. Now remember, this is half of the journey though, right? And so if I want the total time, then I'm going to have to double that to get a final answer. Okay? And then the height that the ball will go. So we're going to have, we want to know y final now. Okay? And we want, if we just solve for time, we'd use the 0.42 because this is where we're talking about, right? We're not talking about the end of our journey. So we'd use the 0.42 here. But if we can use an equation without time, there wouldn't be any problem with that. And there is one we could use. It's the velocity final squared equals velocity initial squared plus 2 times by acceleration times by that delta y. And then the final velocity is 0. The initial position is 0. And so I subtract my initial velocity to the other side. So negative velocity initial squared will equal 2 times by acceleration times by y final. And I'm solving for y final. So I will divide by the 2 and the acceleration. Okay. And so then that will give me a y final number. Okay. Okay, one moment and we'll continue this problem. Okay, so now I'm going to plug in those numbers. So we're going to take this negative velocity initial, and again, it's important to remember, like, this is in parentheses. We have a negative outside of that. So we solve for that initial velocity. So I'm going to grab that 4.133 number in my calculator. So it'll be negative that number squared. Okay, and divided by 2 times by negative 9.81. And that gives us a y final, or a maximum height, of 0.87 meters. Okay, let me extend that. Okay, so we now have figured out the time of the entire trip, and we've figured out that height, how high will the ball go, and now we want to know what is its range. Essentially, it's saying what is the x final. Okay. If we can, since this is all on the same plane, if we figure out this distance, then we can double it to figure out the other. Okay, so again, this isn't true if like we're on a tabletop and we're landing somewhere above or below where we started. But if we land in the same y component, right? We start at the ground, we end on the ground, then we can double that distance to figure out the total distance of the trip. So we know our time component right there, 0.4213, etc. And with all of our, these were all y-related equations, with our x, we should use the third equation that we had down in our notes. So that's x final equals x initial plus velocity initial in the x multiplied by time plus 1/2 acceleration time final squared. And what's nice about this is the acceleration is 0 and x initial is 0. So that's 0 and that's 0. So x final will equal velocity initial multiplied by time final. Okay. So I'm going to plug those numbers in. So I'm going to take that x initial on the 6.6 number and multiply it by the time component, the 0.42, and I get 2.78709. But then I'm doubling it to figure out what the very end is, because that's halfway, and we're going to figure out the other half. So that final answer, 5.57. And we're working with 2 sig figs, so I'd probably round that up to 5.6. Okay. Okay. So there's projectile motion on an angle